In this video, we will address the question of charging your battery via the vehicle's alternator. Many of you want to upgrade your setup to a lithium battery, but I still see too many people sticking with the battery isolator. And this mistake can be very damaging for your battery. So, we are going to look at why it is important to be properly equipped with a charger compatible with lithium batteries, specifically with DC to DC models. But even with that, many mistakes must be avoided to maximize the efficiency of your charger, protect your alternator, and avoid wasting fuel. Finally, we will see how to calculate the charging time of your battery with this type of charger. And in reality, is it really essential in an installation? In short, before we begin, you'll find our electrical diagram pack in the description. Also remember to subscribe to the channel, give a like, and feel free to ask your questions in the comments. So yes, a DC to DC charger is essential when you want to charge a lithium battery from a vehicle's alternator. Alternators were designed to charge lead-acid batteries, which have high internal resistance, and this resistance naturally limits the charging current. On the other hand, lithium batteries have a very low internal resistance. This means they can accept a very high current when charged directly. As a result, the alternator may supply too much current, which can make it overheat and eventually damage it in the long term. Not to mention the damage to the battery. Because let me remind you that even for a lithium battery, there are recommended charging currents depending on its capacity. For example, here with this Power Queen battery of 200 ampere hours, with a battery management system of 200 amperes. The continuous charge and discharge current is indeed 200 amperes, but just below, we see the recommended charging current is 40 amperes, which is 0.2 C of its capacity in reality, so you can't just do whatever you want either. That's the first point. But then, lithium batteries require a specific three-stage charging curve: bulk, absorption, and float, which traditional battery isolators do not manage. The DC to DC charger limits and regulates the power drawn, preventing overheating or failure of the alternator, while also limiting the charging current of the battery. Also, a DC to DC charger is suitable for so-called smart alternators. It forces the charging of the auxiliary battery, even if the alternator naturally disengages, because these alternators stop charging once the starter battery is full. That covers the framework of this video, and the first important message I wanted to share with you. As for installing the DC to DC charger, we will take a common example with the Orion Smart, the 12 to 1230 amperes model. So here, one side is connected directly to the starter battery, and the other to your lithium battery. Important point, for cable lengths, I recommend installing the DC to DC charger as close as possible to the starter battery, in a well-ventilated area, because the more it heats up, the more its efficiency drops. You can refer to the table easily found in the Orion Smart manual. Personally, regardless of cable length, I chose 16 square millimeters for a total round trip length of about 4 meters. When you calculate your cable diameter, always oversize, it's better. This is not where you want to cut costs, I'm telling you again. As for the fuse, under 12 volts, the recommended value by the manufacturer is 60 amperes, at least on the starter battery side. On the lithium battery side, you can slightly reduce the fuse rating because you'll see that we will never actually reach 30 amperes. I'll explain why in a moment. Or you can leave 60 amperes. This protection will serve for short circuits. The wiring is not finished yet because I need to tell you about these 3 small electrical diagrams. Choosing the right one can really impact your fuel savings and the protection of your alternator. As you can see here, solutions 2 and 3 seem very practical because you can bring a positive or negative wire to the green terminal block, which serves as the ignition trigger for the Orion. This is most often done by turning the ignition key to start the engine. And then there's also the first solution, which is a shunt. It can be triggered by turning the key or done manually. Personally, I chose to tap into the positive red wire of the cigarette lighter that turns on when the ignition is activated. The problem is that during the summer season, my DC to DC charger is useless. The solar panel covers all my needs. So I added a switch that allows me to cut the circuit in summer or when I know the battery is sufficiently charged. This is an important detail that lets the system work automatically, but still be manually deactivated. The mistake is really not disabling the DC to DC charger when the battery is fully charged. Another common mistake is leaving the engine running while stationary to recharge. There's nothing worse in the long term for ruining your alternator. It's designed to charge while driving, not while parked. A common question is, how long does it take to charge your battery with a DC to DC charger? If you have a 12 to 1230 amperes model and a battery with a capacity of 100 ampere hours. First, 12 to 12 means that we are converting from 12 volts to 12 volts, and 30 refers to 30 amperes, but we will never actually reach that value. Let me explain. This 100 ampere hour battery has a voltage of 12.8 volts, meaning a total capacity of 1,280 watt hours. I've seen some people make the following calculation. 30 amperes multiplied by the charging voltage of 14.2 volts equals 426 watts. And from that, they deduced that 1,280 watt hours divided by 426 watts equals about 3 hours for a full charge. But that is wrong. It is clearly written on the Victron that the maximum power is 360 watts. So in reality, it would take more than 3.5 hours. The correct calculation is to take 360 watts divided by 14.2 volts, the charging voltage, which gives us about 25 ampere. So here we are, dealing with a theoretical value. With efficiency losses due to heat and so on, do not be surprised if you're getting around 20 amperes with this type of device. So to fully recharge a 1,280 watt hour battery, the charging power would be 20 ampere multiplied by 14.2 volts equals 284 watts. Charging time: 1,280 watt hours divided by 284 watts equals about 4.5 hours. This is much closer to reality for a 100 ampere hour battery. 20 amperes of charging current is already very good as a complement to a solar setup for most people, but nowadays, with lithium, we are increasing all our capacities. So if you want more power, Victron recently released a new model, the Orion XS, which has been completely redesigned with an efficiency of 98%. And with 700 watts divided by a charging voltage of 14.2 volts. You can see that we are close to the advertised 50 amperes this time. However, be careful with the type of vehicle you install this device on. Always check the power of your alternator. On a camper van, we most often have an alternator of 120 amperes. So in that specific case, we do have some margin. Of course, it is more expensive, but it still remains more economical and more efficient than having two 30 ampere models in any case. That's it. Let me know in the comments if I forgot any points that could help you with your setups. Don't hesitate to subscribe and like this video if you enjoyed it.